it recently on the internet for a very, very reasonable price. In fact, I got even a spare replacement part with it. I'll reveal what that part is in a moment, but as usual, when something is extremely reasonably priced, far better than you would usually have to shell out for something like this, you could always suspect there is a catch, and indeed there is a catch. You see, the seller told me that the end stage of the amplifier is broken, and he had started working on this tuner amplifier to, I guess, repair the end stage of the amplifier, and then somewhere along the way he just gave up. So I think the best thing to do now is to have a look inside. Alright, I released the screws from the bottom of the case, so there are two screws there and two there. But I heard quite a heavy clunking sound inside, so let's put the tuner amplifier back flat and then see if we can slide the top cover off of it without causing any more damage inside. Alright, here we go. Going to slide open the case. Alright, here we go. Okay. The case is off. Alright. So now, what are we going to find inside? Oh dear. Okay. Well, I found this lead weight rolling inside. Ouch. Oh yeah. So this is the tuning knob right here, and my guess is this weight was fitted on here. Yeah, something like that. But it was loose, so I'll have to find a way to attach it. To be able to work on the PCB, I should say PCBs, although I think this is just one large PCB. Either way, to be able to work on it, I need to be able to access it from the bottom. Now, I've got a huge problem here, namely the bottom of the amplifier is solid, just one solid steel surface, and in fact the whole cabinet is practically one piece. Yeah. So to be able to unmount the PCB to work on it, I will need to lift it out somehow, and I think I identified how. It's a little bit involved, but basically to detach the PCB I need to detach this whole part here. Yeah, the transformer is a part on its own, and I only need to disconnect it from the rest of the PCB. The PCB itself is attached to the heatsink of the power chip, yeah, the output power chip right there, okay, and it's attached to the rest of the cabinet with a number of screws. So I identified 2 screws on this side. I also identified 2 screws on this side and 1 screw here. Now you might think, okay, that's enough, that should do it, but no, of course not. If it were that simple, I think many people would already have done it. So basically what I also need to do is to detach the PCB from the bottom of the cabinet, and in fact there are 2 screws to do just that. So 1 screw you see over there, the other screw you see there, alright? And these 2 screws are pretty treacherous. If you don't notice them, then you might be in big trouble. You know, you might damage the PCB. Now, is that enough to lift it out? No, unfortunately it isn't. And the reason for that is the potentiometers you see over there. So the balance, the treble and the bass potentiometers, so those 3 there. And they in fact are screwed to the steel front of the amplifier tuner, so this part over there, yeah. And unfortunately, to reach the nuts that screw the potentiometers to the cabinet, I need to lift up the front bezel of the tuner amplifier. Alright, so there you go. A view from the back side. And remember, now it's on its head, okay, so it's top down. I did do one thing. So for the moment I'm not going to mess around with the front of the tuner amplifier because it looks a little bit brittle and I don't want to break it by forcing it, right? So what I actually did was to reattach the little screw up front here, yeah, at the front of the amplifier right here, for solidity purposes. And let me just clip the front back into position like that, yeah, so as not to break it. Alright, so there. I'll have a look later how to unmount the front. Like I said, it's still hanging somewhere, so it just doesn't want to release easily. so I'll have a look at it later. Basically now that the whole thing has been released from the case, as it were, it becomes way much easier for me to work on the amplifier. So obviously there are quite a few electrolytics to replace, and that's the first thing I'm going to do. So I'm going to replace the electrolytics on the main board, you could say, first. And once all the electrolytics are replaced, I might try to give the amplifier a test run with the new capacitors in place to see whether it still functions normally or not. This is actually what's underneath the top shield. Alright. No, I haven't looked yet at the schematic to see what it is, what this specifically is, but my guess is this is probably some sort of IF stage, okay, for the tuner, because here is a tuning gang, the tuning capacitor. So I wouldn't be astonished that this part here is part of the tuning, really, of the tuner, yeah, the IF stage rather. So you remember that we also lifted a small cover shield, and that small cover was of this box here. Okay, so basically the lid is clamped onto the body of this little shielding box, and to lift it up you use basically the same trick. You wedge a flat screwdriver like this, a small flat screwdriver. You wedge it underneath the one of the legs of the cover, and then you twist it up. Yeah, but it's not easy, and you should take your time to do this, because if you use too much force you might break something. Okay, so do it gently and patiently. Okay, so that way you'll never break anything if you take your time. Yeah. I'd rather not open them, honestly, because they are full of high frequency components that are tuned and quite sensitive. And yeah, if I didn't have to lift the covers, I wouldn't. But unfortunately, there are electrolytic capacitors. Yeah, I know you can't see it. Wait, okay, so hang on. I don't know if you guys can see it better like this. Okay, so if you don't need to be inside of those little boxes, then by all means do not open them. But if there are components inside that need replacing, then you have to. And okay, this one doesn't need lifting apparently. There are no components inside that need replacing, but since I've got the cover lifted anyhow, I'll give it a clean because it's oxidated. Yeah, so there you go. That too is part of the tuning mechanism, let's say. Alright, I did manage to release the front of the tuner amplifier after all, and it's really a sneaky little trick. It turns out that the engineers at Grundig made an extrusion in the plastic right here. You see it? Yeah. And this spot right here fits over this potentiometer here. Yeah. So in fact, part of the shaft of this potentiometer holds at this point here, holds the front of the tuner amplifier attached to the cabinet, and then of course the top clips over little metal brackets, and they are pretty weak. You know, this one is broken here. I'll need to repair it. But these tabs are not very solid, so you need to be really gentle with these and not clip it on, clip it off, clip it on, clip it off many times, or you'll break them. All right. So yeah. Fortunately, I managed to release it without too much trouble, so I could give it a very good clean now, and then repair it where necessary. So the little tab here needs to be repaired, and then this corner here I will need to repair as well. So yeah, there you go. It's as easy as that. Okay, then there's one more thing that I'd like to show, is that when you look right here, there's a little light bulb mounted here to the side of the tuning dial. Okay, so it's a normal filament light bulb. Let me see if I can give you a better shot of it. There. See? This little bulb here, it's just a normal filament. Well, normal. It's a small filament light bulb. Remember, there was a little shield mounted in this part, or on this part of the main PCB, and here it is. Okay, so it was soldered in 3 points, and I had to unsolder it on obviously the other side of the PCB, and it was mounted right here. Okay, so I tried to unsolder it as carefully as possible, not to damage the PCB. Okay, but when I removed it, what it revealed is this little chip you see right here, and that is a dual op-amp for preamplification, in fact. Let me see if I can show you on the schematic the preamp. Here it is. So the preamp, let's see, I don't know if you can see it from there, but okay, so the preamp is marked right here, okay, and in fact what the preamp does is pre-amplify the inputs of the which devices are there here? Oh yeah, cassette, auxiliary, and an external, and a phonograph, in fact, a record player. Okay, so this little op-amp here, this dual op-amp here, provides with preamplification for the inputs of the amplifier. Okay, and it's an RC 4558 PG. Yeah, I'll start by replacing all the electrolytics, and when we're done with that, then we can move on and try to test the output of the amplifier, since at least that's what the seller told me, it's defective, but we only have his word for it, so we'll need to check it. Okay, enough talking, let's get on with it. Very tenacious little booger, but we got him out. Yeah, this is the one we just unsoldered from the PCB, and it's supposed to be a 10 microfarad, and look at the value, it's 34 microfarad, and it's incredibly lossy, so leaky in fact, so 5%. The ESR is reasonable, but it's still a bit on the high side. So yeah, that's why we replaced these capacitors, right? Alright, so I want to localize the electrolytic capacitor that I need to replace, and by using a rather strong flashlight, yeah, I simply shine on the other side of the PCB, on the top side of the PCB, and I see the shadow right here of the electrolytic that I need to replace. Alright, I'm in the process of replacing electrolytic capacitors right now, and on the PCB of the Grundig tuner amplifier, electrolytic capacitors are marked like this: a circle and inside two rectangles. Alright, now the empty rectangle on the left is the symbol for the anode or the positive of the capacitor, whereas the solid rectangle on the right side is the negative or the cathode of the capacitor. Now, fortunately for us, the engineers at Grundig were quite thorough, and they also marked the anode by a little plus symbol, which you see right at my fingertip, right there. Alright, but when you replace electrolytic capacitors or tantalum capacitors, you always need to check the polarity. Alright, so that's very important. Never to place capacitors the wrong way around, because then you're looking for a lot of trouble. Alright, I replaced the capacitors in the back over there of the end stage, and now I want to tackle these two capacitors here, which are the filter capacitors of the power supply. They are both rated at 35 volts, 6800 microfarad, so 6800 microfarad, 35 volts. Now I don't have those in stock, so to speak, but I do have these. So I have Nichikon's 6800 microfarad 50 volts, which would be fine, except that the diameter is far larger, and if I place two of these on the same spot over there, they would never fit. Alright, I unsoldered one of the electrolytics, well, filter capacitors of the power supply, and here it is. And look at this. Isn't this a nice piece of history? You'll notice that at the bottom of the capacitor's legend it says W Germany, effectively saying West Germany. So this capacitor was produced at the time the iron wall still, or the iron curtain I should say, still existed between West and East Germany. So when there was still a Soviet empire, right? Just in case you're not convinced that the negative of a modern capacitor is not connected to its case, let me show you. So I've got the multimeter in the ohms range, okay? So we connect the one end of the multimeter to the negative pole of the capacitor, so to its cathode. Alright, so now I'm going to touch the other end of the multimeter to the housing of the capacitor. There you go. Nothing. So infinite resistance. So the negative is not connected to the case of the capacitor. Okay, and with this old capacitor here, that is in fact different. Yeah. So yeah, it's a small detail, but it could be important if you replace the capacitor. Alright, I learned a little lesson here. Um, Obviously, I misjudged the problem with the output of the Grundig amplifier, and I blew one of my speaker's fuses. Yeah. So for the moment at least, instead of working with a speaker on the outputs, I'm going to work with my ballast resistors first. Yeah, and make a few measurements that way, rather than blow the fuse again of one of my speakers. Yeah. So there's a good lesson for you. If you don't trust the outputs of an amplifier, don't connect your speakers directly to the outputs unless you're certain that they are fused or protected in some sort of way, okay? Uh, because if they're not, you could very easily damage your speakers. Alright, so this is the tuner side of the Grundig amplifier tuner, and the thing you have to look at is this. So right there at the FM decoder, stereo decoder chip, alright, you have two outputs. You have obviously a left and a right channel, and these go through you could say pre-amplifier transistors. Alright, and remember the outputs of the tuner go directly into the amplifier end stage. Alright, so you could say these transistors are driver transistors. Now, like I said, you can't hear a thing from the tuner. It's completely dead. But what we do know is this. So right at the output of the IF stage of the FM, let's say the FM section of the tuner amplifier, there's also this. And this part here provides for the tuning indication, alright, with the LEDs, you remember. So, and we do know for a fact that the tuner bar did respond to me turning the tuning capacitor, alright. So we can be fairly certain that the tuner is detecting radio stations, but is simply not propagating sound to the amplifier end stage. So what we need to figure out first is there a problem with the sound output of the IF stage, so which is formed around a TDA 4100 chip, alright? Or is there a problem with the stereo decoder chip over there, yeah, which takes the output of the TDA 4100 and then decodes it into a stereo signal or mono, depending on the radio station or whether you push the mono button or not, yeah, and then passes on the sound to the amplifier stage. So in all likelihood there is a problem somewhere in this large area. So what I need to check is now is, are these two transistors broken somehow? Both of them? Would that stop the sound going through to the amplifier? Yes, it would. But would both transistors be broken at the same time? Unlikely. It's possible, but let's say it's fairly unlikely. However, this chip, which is an MC1310P, which is a stereo decoder chip, really, does provide for audio output, so a left and a right channel. Yeah. And it doesn't work in either mono or stereo. So I would tend to think that the problem is located around this chip. And I should investigate that, of course. But if you look at this line here, which goes all the way down to there, here, alright, this line, yeah, goes from the MC1310P all the way back to a power supply output. Aha! And the power supply output that I have in mind is this one. Alright, so this part here, in fact, yeah, this part here, yeah, provides with a 13 volt plus minus 1 volt output voltage for the MC1310P IC. So it's quite possible that there's a problem here as well. And that would explain why both audio channels are dead. So if this is dead, then the stereo decoder chip doesn't get any power and therefore won't output any audio. We're trying to trace the FM signal coming from the IF chip, the TDA 4100. Yeah. And we're trying to trace the low frequency signal that exits the TDA 4100, so the FM signal, that goes to the stereo decoder chip, which is the MC1310P. Alright? Now, the signal exits the TDA 4100 at pin 14. And you'll see in the upper corner of the screen a video shot, a screenshot of the oscilloscope. Okay, so we're going to measure the signal at pin 14 of the TDA 4100. Alright, so right there. Alright, so in the upper corner of the screen you'll see a screenshot of the oscilloscope. Alright, so this is the signal that outputs the TDA 4100 IF chip with the FM coded signal. Alright, so if I lift up my probe, the signal is gone. If I touch the pin 14 again, there's the signal. Alright, keep in mind this is the FM signal. Alright, so that's what we're getting right now. So what I need to do now is trace the signal all the way down to the stereo FM decoder. Alright, so I need to find out if the signal we saw on the scope comes in on this pin here, namely pin 2 of the 1310. So let's see if it does. Alright, so we want to see if the signal that we traced on the TDA 4100 comes into the stereo decoder chip, which is the MC1310. So if I touch pin 2, which is the input pin, as you can tell on the screenshot, there's no signal to be seen. Alright, so it's absolutely dead on pin 2 of the MC1310. Alright, no problem. So we know pin 14, let's see, we know pin 14 of the TDA outputs a signal, and that signal goes through two resistors, namely resistor R41, and it should be sensed, let's say, at the output of the capacitor C68, and at the tie point with the resistor R44. Alright, so R41 is a 3.3 kilo ohm resistance, okay, and it's a tiny resistor. I think this is a 1/32 of a watt, okay, so, or 1/16 of a watt. That's possible, a 1/16 of a watt. So it's a tiny resistor, okay. So according to the schematic, the low frequency output signal that comes from the IF chip, so the TDA 4100, should be passing through this resistor. So let's measure the signal at R41. R41 is here, and as you can tell in the upper corner of the screen, you see the signal coming through on R41, okay, coming from the TDA 4100. So let's measure the outer pin of the resistor. There you go, the same signal. Alright, now we do know the signal should also come through here, right at this tie point here, so of R44 and C68. R44 is here, and as you can tell on the scope, there's no signal to be measured. But if I measure here, so at the tie point between R44 and C68, which is this capacitor here, we are getting a signal. Alright? But at the other side of the resistor, we're getting nothing. Absolutely nothing. It's dead. So chances are this resistor here is broken. So let's investigate a little closer. So I don't know if you guys can see this, but right here, the PCB has been damaged in the past. And I know it's a bit hard to see it, but right here you can see a break in the PCB, alright? So this area here, there's a break that goes across these two traces here, okay? And one of these two traces is what conducts the FM signal to the stereo decoder chip, alright? So, yeah, the PCB has been damaged here in the past. So, what I need to do is effectively repair these two traces here. Yeah. Alright, I repaired all the broken traces, and there were quite a few. Well, 5 to be exact. And I used wire wrap wire to repair the traces that were broken. In fact, as it happened, the traces that were broken influenced mainly the AM and the long wave part, and partially the FM part. Yeah, the FM being here, this part here, and the AM and long wave being the two wires underneath my thumb. Alright, so I repaired them, and normally they should work. So what I propose to do, well, maybe you could say this against better judgment, is to hook up the amplifier to the speakers and give it a try now. Yeah, and I mean, if I don't exaggerate with the volume and everything, I think the speakers should be safe. Alright, so what I think happened is the reason why there is a break underneath these two switches you see right there, yeah, or maybe even under the third switch over there. What happened was, in my opinion, somebody in the past dropped something really heavy onto the switches, or maybe even pushed too hard on the switches, and therefore the PCB, the print board traces really broke underneath. Whomever it was, I don't know, but it is my guess that the person who replaced the original TDK 461 end stage chip by an STK 463 was probably the culprit. Alright, so, or maybe the one who sold me this tuner amplifier. Either way, yeah, I guess that was or is the reason for the break on the PCB. Now, the other thing that I wanted to show you is how I mounted the new filter capacitors. I in fact used little adhesive feet like this. Alright, so, and I mounted them on a spot where I have some room for them, and I attached the filter capacitors with zip ties to those little feet, which are in fact designed to accept zip ties. You see slots in the top of those little mounts, so you can pass zip ties through them in two directions really. That is exactly what I did. I used two zip ties per capacitor to attach them. The blue tape you see around them is just to make sure that the zip ties can't slide. Alright, so there you go. That's how they are mounted. So in the end, what can I say about the amplifier? Well, as I said before, somebody in the past damaged the PCB at the selection switches for the bands, you know, these three here. So FM stereo mono and long wave. So these and long wave and or AM, yeah. So these four switches really, the traces towards them were damaged. Okay, so by whomever opened up the tuner amplifier, my guess is it was the person who replaced the STK 461, which should have been originally mounted inside of it, by an STK 463. And it's, in my opinion, it was probably because the STK 463 has a slightly higher wattage, output wattage, than the STK 461. Yeah, I mean something like 25 watts instead of 20 watts. Yeah. But yeah, in doing so, the person who did it damaged the PCB, and he probably didn't see the damage, and then went after replacing the STK output chip, decided to test it, and then noticed that neither the long wave or the AM band worked, and the FM band worked only partially, and weakly at that. And he probably looked for the error inside the tuner amplifier and couldn't find the reason, and probably got frustrated with it. And the one who sold me the amplifier told me that he had bought an original STK461 chip to replace, according to him, the defectuous STK463, which is built inside. So yeah, what can I say? Well, the seller probably mistook the fact that one of the two channels, for FM at least, didn't work as a problem of the output chip. But it wasn't that, of course. It was simply a break in the traces on the PCB. So there you go. The tuner works, the amplifier works. So what have I got to do now? Well, I think the next thing I'm going to do is to clean everything, inside and out, give the potentiometers good cleaning and a little bit of greasing, and I'll clean up the front and everything, and then once all that is done, then we will reassemble the whole thing and have a final look at it working. Well, this is a last view uh, of the underside of the PCB, cleaned and reassembled. And here it is, as it is, cleaned, and all the old parts have been replaced. Um, as I showed at the beginning of the video, this corner here of the front panel, or the bezel, the front bezel in fact, was broken off, and I wanted to repair it as well as I can, of course, and for that I used an empty plastic box, which was originally used for containing screws, right? Now, and I used part of the frosted side of the box, and it has a thickness pretty close to what I would need for this edge here. Okay, it's an easy material to cut and to clean, and by the way, it seems to be a food grade plastic. Don't know if you can see this, but right there, right? You see those symbols? Those mean that this plastic is actually food grade, but it doesn't really matter whether it is or not. The thing is, it's useful to repair a little damaged part of a plastic front like this. You know? Obviously, I can never get it quite exactly the same as the original plastic, but that wasn't my intention. My intention is to make the corner structurally solid again, and then to, let's say, cosmetically give it a slightly more correct coloring, you know, like matte silver like this. Alright, so but basically I won't try to hide that I repaired it. Like I said, the goal is to make the bezel structurally solid again, and then, you know, yeah, to make it a little bit more visually attractive. Alright, a final look at the reassembled Grundig R-400 tuner amplifier. I'm going to run it at medium volume, and I'm going to go through all the stations. I'm going to scan through all the stations of the FM band in stereo mode. But obviously, for copyright reasons, I'm not going to linger on any particular station. However, I just wanted to give you a final overview of the tuner amplifier as it is now, restored and cleaned and reassembled. And for those of you who are curious, what I replaced, well, these are all the parts that I replaced. Okay, so there are, roughly speaking, well, I'd say 25 capacitors, electrolytics, of course, and 2 power resistors of 0.22 ohms, 5 watt. Alright, now I should say that most capacitors measured out, let's say, reasonable. I mean, they probably could have lasted a little while longer. Just a few of them were really leaky. I mean, electrically leaky. Like almost a short, really. The others measured reasonable. Yeah. Now, since I was going to make the effort to replace at least the leaky capacitors, I just thought it would be far smarter to replace all the electrolytics, right? So there you go. You'll have to be a little bit handy, and you'll have to have some patience to do the same thing. But in the end, it's pretty rewarding in the sense that this tuner amplifier performs rather well. Don't expect, of course, a huge performance from it. I mean, in the end, it's only a stereo 25 watt per channel amplifier. Okay, so it's not a beast of an amplifier, but for, let's say, an average hi-fi installation, this tuner amplifier would perform rather well. So there you go, the Grundig R-400. So let me just scan through the FM band and make you enjoy the sound quality.
Ik spreek jullie vanuit Los Angeles, waar ik de kans heb om nieuwe tracks te positeren. Over nieuwe tracks gesproken, laten we direct deze beat beginnen. so I won't get help them to bury the lie.
Well, there you go. A final look at the Grundig R-400 stereo tuner amplifier. I hope you enjoyed watching this restoration video, and I hope I'll see you all back for another episode on my channel. Thanks for watching.